Okay, parametric equations, 5.1 on page 281 talks about plane curves and parametric equations. A parametric equation is when you take x and make it a function of time and y as a function of time. And now for each value of t, you trace a point x of t and y of t. And as t varies, x and y varies and traces a parametric curve. T is called the parameter. T is called the parameter. And a parametric curve has an initial point and a terminal point, meaning there's direction. If I say sketch the curve of a parametric equation, you must show direction, even if it doesn't ask for it. You must show direction, no exceptions. So, I could do this two ways, and this is on page 290. I'm going to do this two ways for you really quick. You notice x is a function of time and y is a function of time. The long way of doing this is for you to follow directions. It says you graph each parametric curve, and then they say after that, then find a rectangular coordinate of the curve. Instead, I'm going to do those backwards. I'm going to find this first, then graph that. But let me do the problem as it is asked. I'll take t equals 0, t equal 1, t equal 2, basically three values. Now, if t equals 0, I notice that x right there would be, if I put a 0 there, that's a -3 for x, and a 0 therefore for y. -1, -2, -3, 1, 2, 3, 4. That's the first point I come across. This is at t equals 0. If I move to t equal 1, put a 1 right there, that will be a -2, and a 1 right there, that will be a 6. -2, 6. I'm going to shift this down just a bit. -2, 1, 2, 3, 4, 5, 6. This is where I am. So this is where I am right now. This is where I'm going to be a minute from now. And at t equal 2, I am going to pick, let's go with green. T equal 2. If I put a 2 right there, that's a -1, and a 2 right there, that's 8. 4 plus 2, so -1, 1, 2, 3, 4, 6, 7, and 8. And this is where I'm going to be 2 minutes from now. Now, the fact that those are linear, the fact that this is t and t linear, that tells me that, you know what, I should connect this with a straight line. But the direction is a must. The direction, as t increases from 0 to 1 to 2, there's a direction. So, this is doing the problem kind of like the brute force, the wrong way, the long way. And then they ask afterwards, hey, can you eliminate the parameter? If x is a function of t and y is a function of t, get t out of the equation. So can't I say t equal x plus 3 by moving the 3 over to the left-hand side? Cluttered with all of these colors. And can't I take this now, since t equal that, and replace it by that t in the second equation? This is the system of equations. That's 2 into, and t, we got t to be an x plus 3. So I get y to equal 2x plus 6 plus 4, or y equal 2x plus 10. The benefit out of this, I know what that graph looks like. I'm going to take this and I'm going to use the highlight. I want to graph this line. Well, I know how this graph runs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And a slope of 2. Rise 2, run 1. If I connect this with a line, and again, I'm using a hard to see color, do you see what happens? Instead of me picking all of these points, I'll get this whole line. And now, instead of me guessing what those are, you know, imagine there were 10 points, not 2 points. Imagine says t is between 0 and 20. Then you're not going to pluck 20 points. Instead, you know that all of these points will lie on this line. All what you do, take the beginning take the end and at the end and run in that direction. And you'll see what I mean when I do the next set of problems. And I have a long list that I want to do. Let's see how many lectures it will take. Hopefully one. And I want to do few problems. Meaning all the events. Well, so what I'm going to do, I'm going to do the second part first. That is, I'm going to eliminate t out of the equation, come up with rectangular, and then from the graph, I'll plug a couple of values of t, and there it is. Sometimes the parameter is given, and in other problems later on, the parameter is not given. I'll talk about that. Well, here what I want to do, I want to say, well, x squared equals 2t, or t equal x squared over 2. Take what t equal, and throw that in there, and guess what? Y would equal 4 times x squared over 2. Y would equal 2x squared. I know how to sketch a graph of y equal 2x squared. 0, 0. If x is 1, y is 1, 2. If x is 2, y is 8. The graph looks something like this. That's rectangular coordinates. However, I do notice that x is a radical, which means x is always positive. Automatically, I eliminate that part of the graph. And now, to figure out direction, do not think that the graph will always point left to right. Sometimes it happens that way, sometimes it's coming backwards. So be careful with that. Two values of t will do the trick for the most part. I'm going to go t equals 0 and t equals 1, indicating this is where I am right now. If I put t equals 0 right there, x equals 0, 0. So this graph starts right there. Very good. 1 second or 1 minute from now, this is going to be radical 2, and this is going to be 4. Radical 2, 4 is about right there. So I get that we're going to trace this part of the graph, and there's the direction. And that's how this works. Really not much to do here except graph them for now. Same deal here. I'm glancing at this and figuring out, you know what? And I always solve for x if I can, because y as a function of x is something we're used to. If I isolate the radical, because that's what's over there, I'll get that to be x minus 4, and guess what? There it is. If I take this radical, replace it by x minus 4, I'll get y to equal x minus 4 minus 4. And wouldn't that be y equal x minus 8? I know how to graph that. That is a graph 1, 2, 3, 4, 5, 6, 7, 8, right there. You rise 1, run 1. So the line is really, the line looks like this. But there are a couple of restrictions. One, I could tell by looking at the problem, or I could just use what's given. In this case, they restricted the t. If they didn't, I would notice that x is a radical, which is always positive plus 4, and a radical always minus 4. But since they gave me a couple of values of t, especially a beginning, then that takes care of it. I really don't have to work much. But I know that I'm not going to trace this whole line. At t equals 0, if I put a 0 right there, I'll get a 4, and right there I'll get a negative 4. And 1 second after, I am at 5, and 1 minus 4 is negative 3. So I am at 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Ooh, I'm way off. I overdid this. That's okay. It's not that bigger. Okay, now let me fix that. I don't like that. I want it to be perfect. There, much better. So this is the whole line, but I know no matter what I pick is going to fall on it in this case. Here I am right now, and 1 minute after I am at 5, negative 3. So I know the direction runs this way, and I'm only tracing this part of the graph. So I really eliminate that yellow part. And the actual line is right there. and that's the direction in this case. Let me look at one more. Again, I would say, well, let's solve for t. Plus 4, right? And I would take this value and throw that right there. And y would be 4 times x plus 4 over 2. Y would equal 2 into x plus 4. That would be 2x plus 8. So in this case, oh, I'm sorry, forgive me. I meant squared. Y would equal 4 into x plus 4 squared over 4. And that's a parabola shifted 1, 2, 3, 4 units to the left. True? And notice here, they didn't put any restrictions. It could be anything. I noticed that y is always positive, y is always positive. Two values of t will do. T equals 0, t equals 1. And just to ensure, I'm going to add t equal negative 1 just to make sure you see it. So at t equal negative 1, if I plug in negative 1 right there, that's a negative 6. And a negative 1 in there, that's a 4. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. 1, 2, 3, 4. I'm right here. At t equals 0, put a 0 right there. That's a negative 4. That's a 6. And that's a 0. Negative 4 zeros right there. Do you see that I just came down this route? And at t equal 1, put a 1 in there. 2 minus 4 is negative 2. And if I put a 1 right there, that's a 4. Negative 2, 1, 2, 3, 4. So the graph really looks like this. Alright, I could do probably one more. How about here before I take to the next problem, next video? I could say that's 1 over t, and I noticed e to the t is x, so y equal 1 over x. Well, 1, 1, 2, 1 half, 1 half 2. The graph really looks like this, and we know there's a mirror image right there. Representativity. There we go. And now, if I want to pick t equals 0, what do I get? Put a 0 right there. E to the 0 is 1, 1, 1, 1. This is where this graph begins. And how about at t equal 1? E to the 1 and 1 over e. In case you know you forgot, e is 2.71, so 1, 2.1, 2.71 is about right there. And 1 over 2.71 is 0 point some. So I figure out that I'm only tracing this part of the graph. And the rest is not really there. You could erase it, or you could just cross it like that. Either way, I don't mind. So this is where I'm going to stop this video. I'll start the next video. I don't think I've finished the next one. On the next, I start the next problem in the next video.